Hello everyone. We are already discussing about discrete mathematical structures, right? Discrete mathematics subject. So in the previous example, we discussed about truth tables. In the previous class, we discussed about truth tables. Now we'll discuss a concept called logical equivalence of truth tables. So logical equivalence using truth tables. Okay. So what is this logical equivalence of a truth table? So we have some propositions like P tends to Q, so which is logically equivalent to P or Q, let us assume. So the symbol for logical equivalence is like this. For example, if I have like this, and just an example, okay? So P or Q, let us assume. That means we should show that this LHS is equivalent to RHS. So that is logical equivalence of logical equivalence, and we should prove this using truth tables. So now we will see examples of logical equivalence using truth tables. So what is logical equivalence here? Two propositions. So let A and B are two propositions here. So two propositions A and B are logically equivalent if and only if they have same truth value for every choice of truth value. So what is logical equivalence here? Logical equivalence here. Two propositions A and B are logically equivalent. So when will we say that? If and only if they have same truth value for every choice of truth value. So A equal to B. So the symbol is this one. A equal to B. So A logically equal to B. So we'll solve an example so that we'll get a clear idea about this. So my example is, so this is important. So P or Q and negation P logically equivalent to negation P and Q. So we should show that this one is equivalent to this one. That means the truth value should be same. Okay. So now we'll solve this example. Okay, so what you should see carefully here is how many values are there. Values in the sense, for example, we should write the truth values, right? So do we have R here? So we have only P and Q. Okay, so we should check how many propositions do we have. So we have only P and Q. If you see the whole equation here, we have only P and Q. That means we have 2. So 2 power 2 will get 4 truth values. So 4 truth values in the sense true, 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 false, false, true, false, false. Okay. So if we have R also here, then P, Q are total 3. So 2 power 3 we would have used 8 truth values. But here we have only P and Q, so we should use only 2 power 2, that is 4 truth values. So now let's write our truth table here. P, Q. Okay, so what I said, we will have 4 truth values. True, 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 false, false, true, false, false. Now we have negation P here. So negation P. So what is negation? So negation is exactly opposite. For example, if we have true, negation of, for example, if P is true, then negation of P becomes false. Okay. If P is false, negation of P becomes true. Exactly opposite. So what values do we have in P? True, true, false, false. So what about negation P then? False, false, true, true. So false, false, true, true. Now we shall write P or Q. So P or Q. So what is truth table for P or Q? Or if any one a proposition is true, it will be true. If both are false, it will be false. So that is OR, right? So what about and? Both should be true, then it is true. Or else in any other case it will be false. But what about or? Either one can be true, then it will be true. So if you see P and Q. So true, 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 false. Either one can be true, right? So I have true here, true, false, true. Here I have true, true. Both are false, I will get false, right? So now this is P or Q. So what is my total equation here? P or Q. So let me call it as X. Let me call it as Y. So now X and Y. Okay, or Y and X, whatever. Okay. So now I should check these two. So what is and truth value here? So true, 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 false, false, true, false, false. So what is and? Both should be true, then only it will be true. Remaining all cases false. Okay. So what happens here? True, false, false, false. Okay. So what I get here? False, true, false, false, true, false, true, 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 false, false. So this is my value which I got for this one. Now I should show it is equivalent to negation P and Q. So I already have negation P. Okay. So negation P and Q. So this one and this one, and my truth table is and. Okay. So what is and here? If both are true, then I will get true. Remaining in all cases, I will get false. So true, false, 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 true, 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 false, true, false. So you can observe from here that both are equivalent. So false, false, true, false, 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 true, false. So from this example we can say that both are logically equivalent. So I hope you understand this. So what we need to do here? So first we need to solve for LHS. Later on we need to solve for RHS, and we need to check whether both are equivalent or not. So we'll see another example so that you will get a clear idea about this. Okay. So if you see the problem here, prove that P tends to Q tends to R is logically equivalent to P tends to Q tends to P tends to R. So we need to show that these are logically equivalent. So what is P tends to Q? Okay, so it's implies. So P tends to Q means P implies Q. So first we will see the truth table of P implies Q. P implies Q. Okay, so that means P implies Q. True, 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 false, false, true, false, false. Okay. So now what is P implies Q? If P, then Q. Okay. So here in both cases, in true, true I will get true, in false, false I will get false. But in remaining cases, what value do I have for Q? True, false, 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 true, true. Okay. So that means P implies Q. If P implies Q. Okay. For true, true I will get true. Sorry. For false, false I will get true. Okay. And here true, false I will write Q value. False, true I will write Q value. Okay. So this is the truth table for P implies Q. Okay. So what is P implies Q? If P, then implies Q. So for true, true I will get true, and for false, false I will get true. And for remaining cases I will see the value of Q, what I have. So here I have false and true, so I got false and true. So now we will solve our problem. So what I said, before solving our problem we need to check the given propositions. So here I have P, Q and R. If I have P and Q only, then it is 2, so I will give 2 power 2, I will get 4. Now I have P, Q, R, that is 3. So 2 power 3 I should get 8 truth values. Okay, right. So first P, Q, R. Okay, I will write the truth values here. So I should get 8 values, right? So first I will write 4 trues, 4 false. Okay. Next, 2 trues, 2 false, 2 trues, 2 false. Here true false, true false, true false, true false. So I got 8 values here. So this is a shortcut. So for 8 values, half is 4, right? So 4 trues, 4 false. In 4, the half is 2 again. So 2 trues, 2 false, 2 trues, 2 false. In 2, the half is 1. So true, false, true, false, true, false, like that. Right. So now Q tends to R. So what is Q tends to R here? What I said? What is Q implies R? So if Q, we should check the values of R. So in 2 cases we can straight away write. That means for true true we'll get true and for false false we'll get true. So first let us check. Here I have true true, directly write true. And here I have false false, directly write true. True true, true. Okay. And here I have false false, true. So what about remaining cases? In remaining cases we need to check the second one. Here Q tends to R, so I need to check the R value. So I have F, so I write F. Here I have T, write T. Here I have F, write F. Here I have T, write T. Okay. So what is Q implies R? So first check for truth table, true values. That is, if we have true and true, directly write true. If I have false and false, directly write true. So first I have filled this true, 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 false, false, true, 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 false, false, true. In remaining cases, we need to check Q implies R, right? So I need to check R values. So R I have false, directly write false, true, true, like that. Okay. So now P implies Q implies R. Okay. So P implies Q implies R. So now this is P and this is Q implies R. So now check these two, this one and this one and this one. Okay. So again implies, right? So what I need to do? First check true, 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 false, false, true. So true, 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 false, false, true. So remaining all cases I have different things. So now P tends to Q implies, P implies Q implies R. Now I need to write the Q implies R values. So here I have F, F. Here I have T, T. Here I have T, T. Here I have T, T. Okay. So I hope you understood. So first P implies Q implies R. First check for true, true and false, false values. So true, true, directly write true. And true, true, directly write true, false, false, true, false, false, true. And remaining cases, what happens? We need to check the second one values, that is Q implies R values, and directly fill it. Okay. So next is P implies R. So this part is over. Okay. So now I need to check whether I should get these values for here or not. Now P implies Q and P implies R. So this is X, this is Y. X implies Y. So what is P implies Q? So this is P and Q. Okay. I hope you can see it. So P and Q. So true, 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 false, false, true, false, false, true. Okay. So remaining cases, directly write the values present in Q. So false, false, true, true. Okay. So what I got here? True, true, false, false, true, 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 true. Okay. So now P tends to R. So this is P, this is R. Okay. So check these two values. True, 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 false, false, true, false, false, true. Okay. So I think you can't see it, right? True. Okay. 1 second. Okay. So true. And remaining write directly R values. False, false, true, and true. Okay. So now P tends to Q implies P tends to R. Okay. So this one implies this one. So true, true, true. False, false, true. True, true, true. True, true, true. True, true. Okay. So remaining cases, write the values present in P tends to R. So false, true. Now check this one. This is LHS and this is RHS. So both got the same value or not. So if you check here, what I got? True, false, true, 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 true. So now check here. True, false, true, 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 true. So with this, I can clearly say that these two are logically equivalent. So this is example 2. So previously we discussed about example 1. This is example 2. And now we will see example 3 also, so that all your doubts will be clear. So if this is the third problem, this is most important problem, you can mark it. So this is asked in many examinations. So here, prove that P double implies Q. What does it mean? It's biconnective. So P double implies Q. So previously we have seen P implies Q. Now it's P double implies Q. So prove that P double implies Q is logically equivalent to P tends to Q and Q implies P. So P implies Q and Q implies P, and also is logically equivalent to negation P or Q and negation Q or P. So here, how many propositions do we have? We have only P and Q. So we have only two values, that is 2 power 2 will get 4 truth values. So if we have R also, then P, Q, R are 3, so we will get 8 truth table values. But here we have only P and Q, we will get 4 truth table values. So how we need to solve this problem is most important thing here. So first I have written P and Q. Okay. So P and Q, write down true, 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 false, false, true, false, false. Okay. So here I have negation P. Here I have negation Q. So what I wrote here, negation P and negation Q. So what is negation P? Exactly opposite of P. So I have true, true, false, false. So negation P becomes false, false, true, true. Okay. So now negation Q, exactly opposite to Q. False, true, false, true. Okay. Now P implies Q. So what I said for P implies Q? If for two truth values, true, true will get true, and for false, false we get true, and remaining we need to check the second one, that is if P implies Q we need to check the Q value. So here P implies Q, true, 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 false, false, true, and remaining case we need to check Q value, that is false, true. So here I have false true, right? So I will get false true. Q implies P, the same manner. So true, 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 false, false, true. Now it's Q implies P, right? So I need to check P. P is the second one. So true, false. Okay. So here I have P tends to Q and Q tends to P. What are they asking? P tends to Q and Q tends to P is also logically equivalent to, they are asking like this, which is also logically equivalent to P double implies Q. So now solve this. So I have P tends to Q and I have Q tends to P, and they are asking to perform AND operation. So what is AND operation? If both are true, we will get true. In remaining all cases, we will get false. So this is true, true, and this is true. Both are true, true, true. Remaining all cases, false. Okay. So now P double implies Q. So what is P double implies Q? P double implies Q are nothing but if both are true, we will get true. If both are false, we will get true. In remaining all cases, we will get false. Okay, so what is P double implies Q? P double implies Q means if and only if, remember. So what is P double implies Q? If P and Q are true, we will get true. If P and Q are false, we will get false. But in remaining cases, we will get, if P and Q are false, both are false, we will get true. If P and Q are both are true, we will get true. In remaining all cases, we will get false. So if we see here, P double implies Q, what is P? True, 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 false, false, true. Remaining all cases will get false. So what are they said here? P double m plus q should be equivalent to P tends to q and q tends to P. That's the first part, right? So this one, true, false, false, true. P tends to q and q tends to P. So what about P double m plus q? True, false, false, true. Both are same, right? So now we need to check the third part. So x is a negation P or q. Okay. So here I have negation P and here I have q. So what is or? Either one can be true, then or the answer will be true. Okay. If both are false, it will be false. So negation P or q, right? So this one. So true, false, true. False, false, false. True, true, true. False, true, true. Either one can be true, right? So coming to negation Q or P. So this one and this one. So true, false, true. This one, negation P. True, 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 true. False, false, false. False, true, true. Okay. So here what we got here? For negation P or Q, true, false, true, true, true. For negation Q or P, true, true, false, true. So now what is our last operation? Let us assume this is x, this is y. Negation P or Q and negation Q or P. So x and y. I have an AND operator. So what is AND? If both are true, true. Remaining all cases, false. So true, true, true. False, true, false. True, false, false. True, true, true. So this is our third value. If you clearly observe, true, false, false, true, true, false, false, true, and true, false, false, true. So with this example, we clearly say that all the three are logically equivalent. So this is all about logical equivalence using truth table. So this is a compulsory question and most important question as well. So I hope you understood the concept. So the students who are watching my channel for the first time, I request you to please subscribe my channel and please share my videos to your friends' WhatsApp groups who are studying in different other colleges, and please tell them to subscribe, and please support my channel in all possible ways. Thank you very much and have a wonderful day.